यस आमना मरियम तो कुछ नहीं बोल रहा बताओ। ये गलत बात है। आमना कुछ तो बोलिए। नहीं कुछ नहीं बोलना है। यस मरियम टेल मी। हाँ मरियम। आपकी आवाज नहीं आ रही मरियम लोहानी। हम्म, आपकी आवाज ही नहीं आ रही है। Before moving to see, in the last lecture we have done a very small section of Halloween. That was just an introduction. And in general, when while we are studying organic chemistry, then there are a few things that we will always do. So there will be some chapter. Okay, this chapter will be some functional group, in Halloween, yeah, alcohol, phenol ether, yeah, aldehyde, ketone, carboxylic acid. These type of chapters name will be there. So general thing that we are going to do is method of preparation. Then you will do the physical properties, and then you will do the chemical properties, right? So this will be the general trend that we are going to follow in all these chapters. But in this chapter, Halloween, there are a few things that we have to teach you extra. For example, what we have done allyl halide, vinyl halide, benzyl halide. So all of these things are going to be repeated in the alcohol chapter. Also, you can have allyl alcohol, vinyl alcohol, benzyl alcohol, right? And instead of haloarine, you will be having phenols. No, you will be having phenols. Benzene ring with an OH. Same thing you can have with amines also. Allyl amine, vinylamine, benzylamine, and all of those things. Okay. So similarly, in this chapter, we are going to just revise a bit of isomers. Okay. Now, whatever we are doing for the isomers of haloalkane can be applied to the isomers of alcohol also. Okay. Okay. Try the topic's name: isomers of haloalkane. But you have to extend this to isomers of alcohol also. Please write the topic: isomers of haloalkane. Now, there are two different types of haloalkane. There are two different types of isomers that we are going to learn in haloalkane only, right? So we are not going to do anything very fancy, very simple things we are going to learn. If you must know already, we are just revising this. If you don't know, then it's even better that you are learning something new. So basically, we are going to discuss two different types of isomers. One is known as chain isomer. The other is position isomer. Now, what is a chain isomer? The chain will be different. This differs in differs in. So by the way, what is isomer? Molecule with same molecule, compounds with same molecule. They differ in the length of parent chain. Length of parent chain. Position isomer में क्या होगा? In position isomer, the functional group or the halogen atom in this case will be in different positions. So they what will happen? Molecules or compounds which have which have same molecular formula but differ in the position of the haloalkane attached. So differs in position of halogen atom. Differs in position of halogen atom. चलिए अब यहां से हम ना कहानी start कर and then uh, you can talk also about it. ठीक है चलिए देखिए I will ask you some questions. We have a carbon atom and there is a halogen atom. One carbon atom. We are taking the case of what? If we have one carbon atom and if there is any isomer which is possible or not. So carbon and there will be one halogen atom X. So what is the parent chain length? It is one carbon. So no matter how you draw it, it will be always one carbon. And on the same carbon atom, halogen will be attached. So you cannot have any other possibilities if you have one carbon. Does that make sense, yes, some people? Amna, Mariam, and Sufyan Taha. If you have one carbon atom, there is only one way in which you can arrange the chain, and there is only one carbon atom in which you can attach the halogen atom. Tell me. Yes, others. Amna, Mariam, Sufyan.
Yeah.
Yeah, there's no other possibilities. If you have two carbon atoms, then C1 and C2. So you can attach the halogen atom here, or you attach here. It's going to be the same thing. Also, first of all, let us look at chain isomer. Now, position बाद में देखेंगे chain. Carbon 1 is attached to carbon 2. That's the only possibility. Na? Even if you write it like this, 2, 1. So carbon 1 and 2 are attached. No here. Makes sense. There is no other possibility always attached to carbon 2. Carbon 1 will be always attached to carbon 2. That's it. Now, if you attach halogen in the first carbon, the second carbon is not going to change anything. Does that make sense, Amna, Mariam? आप लोग कुछ नहीं बोलना है क्या? Amna and Mariam. Mariam, आपको तो आवाज नहीं आ रही है? Please rejoin. Yes, Amna. Make sense?
जी.
जी. When you have then you can have one possibility, that is carbon 1, it is attached to carbon 2, it is attached to carbon number 3. Although you can have different attachments. For example, carbon 1 is attached to carbon 3, it is at carbon 2. But in both of these cases, the parent carbon is always having how many carbon atoms? 3 carbon atoms. 3 carbon. That means the parent chain will always be what? It will be prop. The parent carbon chain, whether you attach 1, 2, 3 or you attach 1, 3, 2, 2, 3, 1, 3, whatever arrangement you are going to do, it's not going to make any difference. The parent chain will always be prop. But yeah, that is one thing is true, that if you see the one carbon and the third carbon, both of these carbons are 1 degree, and this is also 1 degree. But the second carbon atom, this is 2 degree. This is 2 degree. So we can have two different isomers in this case if I attach halogen. So this is the carbon chain, and I am attaching the halogen atom in the first 1 degree carbon, or you can attach the halogen atom in the 2 degree carbon. Now the position of halogen atom has changed, so we can have position isomers even if I have 3 carbon atoms. Does that make sense? Does that make sense? Hayana बताएं. What about others? Amna, Mariam, Taha, कुछ तो बोलिए. बोलो. ठीक है. When we have 4 carbon atoms, don't write these things. Okay, I'm going to write it very properly. Okay. When you have 4 carbon atoms, there are two possibilities. You can have 1, 2, 3, 4 carbon atoms like this, or the other possibility is 1, 2, 3, 4 carbon atoms like this. Now, once you have drawn both the parent chains in different possibilities, once you have arranged the chain, then only you are going to look at the positions. Please keep in mind how I am teaching you guys. पहले chain देख लेना. First, you will see that there is no other possible chain. There is no other chain possible right now. One chain which is completely straight, and एक chain में आपने क्या किया है? एक chain में एक carbon को उठा के बीच में लगा दिया. Right? Now you have to see what are the different carbon atoms. Now, if you look at this carbon, here we have this carbon and this carbon is same. Right? And this carbon and this carbon is same. So you can have two possibilities. आप या तो इस तरह से लगा दीजिए, this carbon, two possibility, or the red possibility will be. So both of these are what? Both of these are positional. Both of these are positional. Now here if you look at, we have two different possibilities. You can either have this possibility, or you can have this possibility. All blue carbon atoms, all of them are what? 1 degree carbon. The red carbon is 3 degree. Take one possibility. So one possibility is when you have something like this, and the halogen atom is also attached here. Or you can have the blue possibility in which you have the parent carbon chain. देखिए पहले chain बनाना है, उसके बाद you have to attach X here. ठीक है. So what about these two? These are two are also position isomers. But if I talk about A and this one, A and B, let's suppose A, B, C, D. ठीक है, ऐसे कर गया. A and C are chain isomers. A and C are chain isomers. So आप chain ही different. But once the chain is same, then you have to look at the position. What about B and C? B and C is also chain isomer. What about B and D? B and D is also chain isomer. But what about A and B? A and B position isomer. Does this make sense? Yes or no? Please tell me. बात आ रही है? अरे बहुत नहीं समझ में आ रही। डज दिस मेक सेंस गाइस? आमना मधु सुफियान। चलिए, अब देखिए, वंस वी हैव अंडरस्टूड दैट वी हैव टू स्टार्ट विद थ्री कार्बन एटम्स, तो देखिए थ्री कार्बन। तो थ्री कार्बन में आपके पास यू हैव टू पॉसिबिलिटीज, बोथ ऑफ दीज आर गोइंग टू बी पोजीशन आइसोमर्स। अब आप यहाँ से चालू कर सकते हैं। तो three carbon atom you can have like this, and here you have a halogen atom, right? Or you can have three carbon chain, and you can have halogen atom here. So if I meaning, then we can write one halo chloro bromo propo जो भी हो जाएगा, one halo, this will be what, propane. This is propane. Now, instead of halo you can have chloro bromo fluoro iodo, all of these things. What like common name is going to be n propyl halide. दिस मीन्स नॉर्मल है ना, 1 डिग्री में जो होता है ना नॉर्मल, जनरली आपको प्रोफाइल हाइलाइट बोला जाएगा तो नहीं का। दिस इज नोन एज आइसो प्रोफाइल लाइट। सो प्रोफाइल हाइलाइट, नो यू कैन आल्सो नेम दिस एज एन हैलोप्रोपेन और आइसो हैलोप्रोपेन। ठीक है, तो दिस वन इज आई पैक, द फर्स्ट वन इज आई पैक, द रेस्ट ऑफ देम आर नॉर्मल। ठीक है, आई विल बी राइटिंग द फ्रॉम नाउ ऑन। के बाद हम सिर्फ और सिर्फ क्या लिखेंगे, आई विल बी राइटिंग द कॉमन नेम, द मोस्ट कॉमन नेम इज गोइंग टू बी, प्लीज राइट दिस डाउन। रेज योर हैंड वंस यू डन। वेटिंग फॉर आमना एंड मरियम। Just waiting for Anna. Okay. Now, in four carbon atoms, so in four carbon atoms, we have two possibilities in the chain. The chain can be arranged like this, or the chain can be arranged like this. Now, in this chain, it is known as N-butane. इसका नाम ही क्या है? N-butane. और इसका ही नाम है isobutane. This is known as the common name for this is N-butane and isobutane. Now, in N-butane, we have two possibilities. As we have all read possibility, in either one of them is same carbon atom. Like here we have blue possibility. So one possibility is, and then you are having halogen atom here. The other possibility is you are having the halogen atom on the blue carbon here. Now the name of this is N-butyl halide. N-butyl halide. The name of this one is Tech-butyl halide. This is from second P carbon. This is Tech-butyl halide. Just try to repeat it like once or twice in 1 or 2 days timing, है ना? इस हफ्ते इसको आप regularly repeat करते रहेंगे, then you will be easily remembering these things. And in isobutane also we have two possibilities. The red possibilities, which is the middle one, and the blue possibilities is the corners ones. All the corner one are same. That is only having how many carbon atoms? They are only having 1 degree carbon atoms. So the rest red possibility will be something like this. Hmm. Wait a second. Okay. So this is isobutyl halide. No, this is third butyl halide. And the other possibility that we have the blue one. Like this you can have. So this is known as isobutyl halide. We'll copy this down. Raise your hand once you're done. Waiting for Mariam and Taha. Just waiting for Taha now. Okay. When we have 5 carbon atoms, 5 तक ही देखना ऐसे तो if you go on, then it will be very difficult. But you have to see till 5 carbon atoms. Now, in 5 carbon atoms, we can have multiple possibilities, not only two. See, one possibility, let me just see. Begin. One possibility is going to be simply This is normal, है ना? This will be known as N-pentane. Then you can have further something like this. This will be known as isopentane. Okay, and you can have one more, I think that will be neopentane. All the carbon atoms are here only. And 5 carbon atoms, as you can see, this will be neopentane. Okay, so there is no other possibilities. There is no other possibility for the what we can say for the fifth one. There is no other possibility for any third case. ये तीन केस आपके पास बनेंगे. Now n pentane में आपके पास तीन possibilities है. Blue and this blue. I hope you can see that. Then these two red, and then you can say that this one green. Okay. Similarly, in isopentane, you have certain possibilities. If you see these two blue are same, then this red one is different, then this green one is different, and then this one is also different. I hope you can see that. Although this pink or the purple and blue one, both of them are 1 degree, but the blue 1 degree is connected to 3 degree, that is red. And connectivity यहाँ पे देखिए, this is 1 degree, it is connected to 3 degree. This 1 degree is connected to 2 degree. That's why they are different. Now, if you look at the last one, then all of these carbon atoms are same. And obviously, this middle carbon is different, but you cannot attach any halogen atom here because it is already having 4 bonds. If you attach one more halogen atom here, it is going to be a fifth bond. And obviously, 5 bond for a carbon atom is not possible. So I want you to draw all the 8 possibilities, I think, right? So from here, we will have 3 possibilities, 3 different isomers. This will give you 3 isomers. This is going to give you 4 isomers. And there is only one isomer possible for 5 carbon atoms in this case. Does this make sense? Yes or no, please tell me.
Yes, sir.
Please draw all the 3 and then 4 isomers in the isopentane case. And from neopentane, you will get only one isomer. Please draw them and then we will name it. 1 degree, 2 degree, 3 degree क्या है ये? वो सारी चीजें आप असाइन कर सकते हैं उसको. There's actually one question in NCERT. Like draw the structure of all 8 isomers of molecule formula C5H11 and name each isomer according to the secondary or tertiary bromide. You have to make a bromide or halide कुछ भी बना दीजिए आप. ब्रोमाइड बनाइए, मेक ब्रोमाइड, है ना. आई एम गिविंग यू वन एग्जांपल. आप यहाँ पे ये बनाना है आपको. फॉर एग्जांपल, if I attach on the blue carbon atom, this will look something like this. 1 2 3 4 5 and the fifth carbon will be having a bromide like this. ब्रोमीन atom here. ठीक है, तो इस तरह का बनाना, ब्रोमीन अटैच कर सकते हैं. चलिए प्लीज कीजिए. Do this and send the answers on my WhatsApp. Sufyan, I'm looking at your answer. अच्छा, एक रिक्वेस्ट है सारे बच्चों से, that please send in like portrait, ऐसे फोन घुमा के नहीं आना चाहिए, फोटो सीधा सीधा भेजने की कोशिश कीजिएगा. N pentane, correct, correct, and correct. For isopentane, you have correct, correct. I can't see the fourth one. आप एक के नीचे एक बना देते ना, ज्यादा सा ठीक हो जाता. I neopentane one is fine. Neopentane halide is fine. Waiting for others, very easy. It's not very tough, guys. What happened? Amna and Taha. इतना टाइम क्यों लग रहा है आप लोगों को? So what I have made is the blue one. चलिए बाकी करते इतना टाइम चलिए. रेड के लिए देखिए. 5 carbon atoms, and here we are going to add bromine. For the green one, here we'll attach bromine. The 4 isomers that is possible for the isopentane case, in this we have going to take the blue one first. This is the chain. And then you can attach the halogen atom here, that is Br. ठीक है. उसके बाद then for the red one, first make the chain, then attach the bromine atom. Then for the green one, first make the chain. दोनों में यही कलर आ रहा है क्या भाई? Just give me a second. And then attach the green one. ठीक है, एक और बन जाएगा यहाँ पे. For the purple one, and for the neopentane case, we have only one possibility. Make sense? Sufyan and Taha? No, Mariam Amna दी गई, लोग Mariam Nahani दी गई. Make sense till here? Yes or no? Please tell me.
Yes, sir.
Taha, आपने कहाँ तक बनाया था?
Sir, I only till and painting.
N pentane only. तो इतना टाइम तो लग रहा था आपको. चलिए, copy this down. Raise your hand once you're done. आमना कहाँ तक बनाया था आपने? यस आमना. आमना जवाब ही नहीं दे रही है.
यस सर.
कहाँ तक बनाया था आपने? डन. आमना डन.
यस सर.
हम पूछते थे कहाँ तक बनाया था आपने, तो जवाब ही नहीं देती हैं आप तो. खैर, चलिए. Now write the heading. MOP of haloalkanes. Method of preparation of haloalkanes. Right. Methods of preparation of haloalkane. So by the way, इसमें ना दो there are two names that you need to remember for the 5-1. एक तो इसका नाम लिख लीजिए, भूल गए लिखने के लिए. This is neopentyl bromide. ठीक है. और एक ये है, दिस इज आइसोपेंटाइल ब्रोमाइड. कहाँ गया? This one. This pink one, it is isopentyl bromide. And I see chloride, iodide, and all of those things can happen. In method of preparation of haloalkane, and we are going to shorten it to MOP in the next cases. Method of preparation of haloalkane means सबसे पहले आप लिखिएगा from alcohols. The A part is from alcohols. Now, in alcohols, the number one part that we are going to see is using phosphorus based reagents. So we have, see, please don't write now, we have alcohol, that is ROH. And there are four different reagents that we can use. Here it is. So let me move a bit more space. बहुत ही आसान है. If you have PCl3, then OH will be replaced by Cl. Please see, or as it is, wherever you have OH, instead of OH, you will write Cl. If you have PBr3, then whatever the R is, whatever the alkyl group is, you will write the alkyl group as it is. Wherever the OH is present, you will add Br there. Next one is red phosphorus plus X2. What is X2? See, X can either be bromine or it can be iodine. So whatever the R is, you will write as it is. Instead of OH, you are going to put X. Now X can be anything, bromine or iodine, है ना? Bromine और iodine में से कुछ भी इस्तेमाल किया जा सकता है. The last one is PCl5, and here also you will write the alkyl group as it is, and instead of OH, you are going to attach Cl. Please copy this down. उसके बाद फिर हम बताते हैं. See, there will be some byproducts also, but I am not writing those because they are not important in this particular case. Whenever or wherever the byproducts are going to be important, I will mention them, and I will also tell you to remember the byproducts. In this case, the byproducts are not very important. So all of these are what? Phosphorus-based reagents. Please copy this down. Raise your hand once you are done. Waiting for Amna. Amna, why you are getting disconnected?
Sir, net problem है शायद.
Raise your hand. चलिए, मूविंग ऑन, ध्यान दीजिए and tell me quickly, tell me where in this अरे ये भी नहीं कहते, इसके लिए भी नाम लेना पड़ेगा। आमना सुफियान ताहा, जल्दी बताओ, हाउ मेनी कार्बन एटम्स? अरे भाई जल्दी बोलो, हाउ मेनी कार्बन एटम्स? गॉड,
What?
हाउ मेनी कार्बन एटम्स?
Two.
I think my connection. Two carbons, right? So two carbon as it is, and instead of OH, what will be right? Tell me, two carbon as it is, instead of OH, what should be there? Instead of OH, Cl.
Cl.
Very good. Not Cl2, Cl3, कुछ नहीं, सिर्फ Cl. अरे ताहा क्या बोला आपने? Cl3 बोल दिया आपने। ताहा आपने Cl3 बोला ना? नहीं नहीं,
Yes,
Cl3 नहीं होगा। Say it will be Cl. Say yes sir, नहीं Cl.
okay, sir.
What? Not
C.
okay sir. Say Cl. Ah, thank you very much.
Cl.
Yes, very good. We have OH like this. How many carbon atoms here? Tell me, guys.
3.
3. And we are reacting this with PBr3. So everything as it is instead of OH. What should we write? Instead of OH, everything as it is instead of OH. Bolo.
Br.
What? Br. Very good. Br. Not Br3. Only Br. You can have something cyclic. डरना नहीं है उससे. You have OH, and you saw here. Let us suppose PCl3. PCl5. So everything as it is. Everything as it is. Instead of OH, chlorine. Similarly, for example, if you have something like this, डरना नहीं है आपको. But please remember, you should have something like this. This is alcohol. This is not phenol. This is alcohol. And here, if you're having red phosphorus, and I2, then everything as it is. And iodine. Chali, copy this down. Raise your hand if you're done. Raise your hand if you're done, guys. Check. Next, using thionyl chloride. Second method of preparation. Using thionyl chloride. This is important. When alcohol is treated with thionyl chloride. What is thionyl chloride? It is SOCl2. Thionyl chloride, they form alkyl chloride, HCl, and SO2. Okay. So what they are saying, when you have alcohol, that is ROH, if you react this with SOCl2, you will get RCl plus HCl plus SO2 plus SO2. That means, for example, if you have something like this, OH and you react this with SOCl2, then you will get something like this plus HCl. See everything as it is, 3 carbon atoms and then OH. 3 carbon atoms and then instead of OH you'll write Cl plus HCl plus SO2. Now, there is an important question that is generally asked. सवाल क्या आता है आपके पास? सवाल आता है why thionyl chloride is preferred method of preparation of alkyl halide from alcohols. From alcohol. आंसर क्या है? आंसर है because the byproducts form the byproduct HCl and SO2 की बात हो रही है. HCl form Cl and SO2 are escapable gases and we get pure alkyl halide without any need of purification. ठीक है, तो इसको purify करना पड़ता है. You can directly get what alkyl. In general, whenever you have a mixture, इसमें HCl निकालते हैं, SO2 निकालते हैं, then you have got ठीक है. There is be no need of purification. Copy this down, raise your hand if you're done. इसमें से बस यही सवाल important है. That is why the byproducts are also important. Waiting for Sufyan and Taha. Just waiting for Taha. Right. Next, using halo acids. Halo acid, hydra acid, ये सारे नाम हैं. This is also important. इसमें important केस है HCl वाला, ठीक है. ये important. बाकी आपके पास और भी केसेस हो सकते हैं. For example, like this, when alcohol is treated with HX, it forms corresponding. It forms corresponding alkyl halide. So basically, ROH plus HX will give you RX. ठीक है, आपको एक हैलो एल्कीन मिल जाएगा. प्लस यू विल गेट वाटर. दैट्स अनदर थिंग. साथ में आपको वाटर मिलता है, राइट? बिकॉज यहाँ का हाइड्रोजन यहाँ का OH क्या बना दिया, देखिए. यू कैन सी वाटर फॉर्मिंग, राइट? नाउ इफ आई टॉक अबाउट द रिएक्टिविटी, reactivity. Then reactivity of HX. If I talk about the reactivity of HX, then HI is what? It is most reactive, followed by HBr, and then followed by HCl. HF is very unreactive. HF reacting either part. Okay. HI, HBr, and HCl. Now, if I talk about the reactivity of alcohol, then in this case, the 1 degree is slowest, followed by 2 degree, and then followed by 3 degree. These are the reactivities. कॉपी दिस डाउन, रेज योर हैंड इफ यू आर डन। उसके बाद हम लोग मेन केस पे जाएंगे। यहाँ तो आपको होपफुली समझ में आ गया होगा, देयर इज नो मच कंटेंट हियर, बट इसके बाद वाला इंपॉर्टेंट। इसके बाद इसी के अंदर आएगा। रेज योर हैंड इफ यू आर डन। Waiting for Amna. Amna, raise your hand. Okay. So since the reactivity of HCl is very less, we use a catalyst here, that is anhydrous ZnCl2. So this is important. Treatment of alcohols with HCl in the presence of and ZnCl2 gives alkyl chloride. Okay. And this particular reagent HCl plus anhydrous ZnCl2, this together it is known as, is aka also known as Lucas reagent. Okay, I will call this as LR. Lucas, and Lucas reagent, it is used for distinction between Lucas reagent is used for distinction between, is used for distinction between 1 degree, 2 degree, and 3 degree alcohols. कैसे? ध्यान से देखिएगा। See, don't write anything. See, when you have 1 degree alcohol and you treat this with Lucas reagent, then you will see no reaction at room temperature. No reaction at room temperature. But when you heat it, there will be white PPT form. White PPT. So white PPT, you know, like if you have chalk powder, and you mix it in water, then you will see something whitish in the complete solution. That is generally known as turbidity. Turbidity भी बोला जा सकता है, turbidity on heating. So if you heat it, then only it is going to form RCl. RCl is what? It is going to be insoluble. That is why it forms white PPT. Similarly, if you have 2 degree alcohol and you use Lucas reagent, then white PPT will be formed. White PPT will be formed after 5 to 10 minutes. That means it is going to take time. But if you use 3 degree alcohol and Lucas reagent, then white PPT is formed immediately or instantly. It doesn't take any time in order to form white PPT. Why? Because we have already seen that the reactivity of alcohol, it depends on 1 degree, 2 degree, or 3 degree. 3 degrees faster, that's why it reacts very quickly with Lucas rate. Copy this down, raise your hand if you're done. Make sense, everyone? Please tell me. Yeah, this is going to be coming again in alcohol chapter. Okay, please write this down. Raise your hand if you're done. Waiting for Amna and Sufyan. Just waiting for Sufyan now. सवाल आ सकते हैं. Distinguishing one propanol and two and what is it? Two propanol. ठीक है, so you write using Lucas reagent. Now the reagent HCl hydrous ZnCl2. You will write propanol will not give turbidity at room temperature, but 2-propanol will give turbidity at room temperature after 5 to 10 minutes. Okay, this is a format that you are going to learn slowly as we proceed in this particular chapter. Okay, this is the format how you are going to write the answers for the distinctions. यही same format पे रखना है वो. सबसे पहले name the reagent and what you are going to use, and then show how this reagent is going to distinguish. Like if there is sample A and B, और आप एक प्रोपेनॉल है और दूसरा 2-प्रोपेनॉल है, तो आप A में दोनों में क्या डालिए? लुकास रिएजेंट डालिए. And let's suppose A ने क्या कर दिया? It does not give any reaction. Then you will say that A is what? 1-propanol. And B it gives after 5 to 10 minutes, and you will say this is 2-propanol. ठीक है? So this is how you are going to write the answers always. Like using Lucas reagent, using water reagent, and then how the two compounds are going to react differently with that particular reagent. Copy this down. Raise your hand if you're done. Waiting for Amna. Just waiting for Amna. So, next one is fourth one. Just a second. Sorry, please write using NABR in the presence of H2SO4. Okay. So basically, what reaction happens here is you have ROH alcohol. Now, obviously, we are seeing the method of preparation from alcohol. So you have alcohol plus you have NABR. So you can have anything BR, KBR, वगैरह भी हो सकता है. But you're having sodium bromide, NABR or KBR bromide, plus you have H2SO4. So what happens essentially is that this NABR and H2SO4 they form HBr, because you will get bromine negative, and from H2SO4 you will get H plus. So they form HBr, और फिर HBr से react करेगा तो क्या बना देगा? This will form RBr. Plus it gives NaHSO4. That is another thing. It's not really important. Okay. So this reaction happens. So similarly, if you have, for example, 1, 2, 3 carbon atoms and OH, so if you react this with NABR in the presence of H2SO4, you will get 1, 2, 3 carbon atoms and Br. Similarly, if you have something like this, OH, and if you use KBr also, for example, and in the presence of H2SO4, then also you're going to get something like this. Now, people thought that a similar reaction could happen if we use sodium iodide or potassium iodide. So they were expecting something like this. Please see, please don't write this last one. Sodium iodide plus H2SO4. Then it would give Ri. But this reaction did not happen. We did not get Ri. So they investigated why it is not giving Ri. So उसको हम लोग करेंगे investigation, but पहले आप इसको लिखिए. Write this down. Raise your hand if you're done. Then we are going to discuss why we cannot use Ki or NaI in order to get alkyl iodide. Waiting for Amna and Taha. देखिए. So what happens is that you have ROH. ध्यान से देखिएगा, लिखना नहीं है आपको. ROH plus you have sodium iodide or potassium iodide for that matter. Potassium iodide का सवाल NCERT में, but that doesn't matter. ना? If you even have sodium iodide, and if you are using H2SO4, then what's going to happen? So sodium iodide and H2SO4 first they will react and they will form hydrogen iodide, HI. Now please understand that you don't have only HI यहाँ पे, और ऐसा नहीं कि you have completely used H2SO4. Initially 1 mole of sodium iodide will react. There will be some H2SO4 remaining. H2SO4 it is a very strong oxidizing agent, and the HI bond it is very weak, है ना? Strong oxidizing agent के साथ क्या होगा? When you have I negative, क्या हो रहा है यहाँ पे देखिए? You have I negative and you have an oxidizing agent. So I negative का oxidation हो जाएगा. What will happen to the I negative if it gets oxidized? It will become I. Okay. So now you have I2 remaining. You don't have HI anymore, because HI whatever HI was produced, it was oxidized by the H2SO4 and it has formed now I2. और I2 और alcohol का reaction हो ही नहीं सकता. That is why we don't get any product. So how are we going to write this down and what we are going to use instead of H2SO4? So please write as H2SO4 is a strong oxidizing agent. It converts hydrogen iodide to I2, which doesn't react with alcohol. Therefore, H2SO4 is not used H2SO4 is not used during reaction of सोडियम आयोडाइड या पोटेशियम आयोडाइड. ठीक है. So what can we use instead of H2SO4? We use mild oxidizing agent H3PO4, which provides HI and doesn't convert it to HI. चलो यहाँ तक लिखिए. Raise your hand if you're done. There will be a small assessment after the class. Please attempt it. 5 questions. So that's it for today, and we are going to look at the next method of preparation from hydrocarbons in the next class. ठीक है. ये सारे method of preparation, these are very important. We are going to learn many things.